It is my great honor and pleasure to introduce Professor Sushil Kumar Saraswat sir. He has obtained his Bachelor of Engineering degree from NIT Durgapur in Chemical Engineering. He then did his Master of Technology from IIT Roorkee and PhD from IIT Delhi and postdoctorate from Virginia Commonwealth University, USA respectively. Now I would request our respected HOD sir to kindly share a few words and invite our guest of today's lecture, Professor Sushil Kumar Saraswat sir. Sir, please.
Very good afternoon to all the faculty members, my dear students. Today, Professor Sushil Kumar Saraswat is with us. He has accepted to deliver his lecture within very short period of notice. We are thankful to Professor Saraswat. He is known in his field of research. I think he will share his valuable ideas with our students. We are already late, Saraswat, and you have to attend your meeting at 4:15 or 4:30. So kindly start your presentation. We will again meet again and again. The IT students is very aspirant of your valuable research papers and research ideas. So kindly, without failing, now you can start, sir. Thank you, sir.
Sir, are the slides visible to you? Okay, sir. Uh, full screen कहाँ से होता है? नहीं नहीं कंट्रोल हम ही लोग करेंगे. Okay, sir. Whenever you want to switch slides, you can just say us to switch them. Okay, sir. Control. यहाँ से next.
Okay, sir, you can start now. Yeah, thank you, sir.
वहाँ नहीं visible है, सिर्फ sir को visible है. Yes,
Yes,
sir.
sir.
You are audible. इधर से mute हो जाते हैं.
Webcam.
Webcam ही लगा.
Yes. Yes, sir. ठीक है सर.
Mute करना Alt plus tab करके plus tab में जाना unmute वाला अभी mute है.
Yeah, mute. फिर Alt plus.
Alt plus tab करेगा तो switch होगा tab.
ठीक है.
Meet वाला में जाएगा वहाँ से unmute मारेगा फिर Alt plus tab करके फिर यहाँ आ जाएगा. अगर कुछ बोलना होगा तो mute होगा.
अभी हम muted है ना.
हाँ अभी mute
कौन सा भी हम बोल सकते हैं.
है. ठीक है निकले तब खाली है. खाली है हाँ silent.
best renewable energy resource is hydrogen energy. The second point is environmental security. When we talk about the security in terms of the environmental protections. So when we emit CO2 or the carbon dioxide in the large quantity, then we think of if it is going to be useful only when we are talking about the security or will give the energy if it is CO2 free. International competitiveness is an example because every country is coming now with more or less, coming up with the latest technological development. So in a mankind where India is going to be play an important role and become the fifth uh, economic country in the world. So there's a large number of renewable resources or the non-renewable sources need or to use for industries or the persons in the industries or maybe the economy sectors. So there is a utmost need to derive and factors why hydrogen is much more useful. So just we talk about the what is actually the hydrogen is. Next slide, please. So just we talk about the basics. Why hydrogen? You just talk about the hydrogen. Hydrogen is the most abundant, but is not clearly visible to all of you because it is normally comes in the form of different fractions, or is not comes as such on the p rate. So, but the reason is it is not never be alone. Means it's come in the compound. For example, if we talk about the water, so in water we have a in a 1 to 1 ratios. Hydrogen is evolved 1 to 1 ratios. So 1 mole of hydrogen that will give you the 1 mole of hydrogen. Water give you 1 mole of hydrogen and 2 mole of oxygen in that. So in that conditions, we get almost 1 mole of hydrogen with the similar conditions. Like hydrogen is evolved as such from the water, and water is a plant enough. Almost all of you know that 78% of the earth is covered by the water. But the problem is, it is very tough to dissociate the water and come up with the hydrogens. So we talk about the technology, how it is helpful and how it is going to produce it from the water itself. And it is going to be the fuel of the stars. So everybody knows that hydrogen is through nuclear forces or the nuclear fission reactions can also emit large amount of the reactions and which is emit the hydrogen energies. Everybody is talking about the even hydrogen bombs and this kind of bombs even, but we are driving or you want to utilize that hydrogen energy in such a way so that it can be used for environmental friendly fuel for the next generations. So let us talk about the properties of the hydrogens. Next slide. The ultimate questions come is why we need hydrogens. So if you see that if you just go to the slides, it will give you a good idea about it. So if you talk about the automobile industries or the nuclear industries or the electricity, it is all generations of the hydrogens and converted this is from the various sources. Like we have a different kind of sources in which that we can get hydrogens, but the condition is critical to produce that hydrogens in such a way that the how we can utilize this hydrogens and how we can produce the hydrogen. So hydrogen energy is the need of the market right now or need of the country. But the problem is we have to do the technological development so we can get the efficiently amount of hydrogens from the various sources. Next slide. Next slide, please. So why hydrogen when it is not the primary sources? Because like for example, methane, or we talk about the like petroleum or the reliance, sorry, the industries of petroleum. We are depending right now with the fossil fuels. Right now, more than 60% of the hydrogen is derived from the fossil fuels or from the coming from the Arabic countries. So it is, but because it is the synthesis process that is very tough to produce the hydrogens from the methane. Till now, we are talking about the process, how it is going to be developed. But right now, why the hydrogen is needed is, uh, okay. So the primary is the best storage, but the problem is just to produce this in this synthesized with the effective methods. And the second is, it is the renewable energy sources, but the problem with this is the storage. So we will talk about this all the factors one by one. So next, coming to the next slide. So then you will have clear cut idea about it. This is the excellent energy carriers, and amount produced from the per kg of hydrogen is very high compared to the most of the fuels that is derived from the any other metals. The second is, hello.
Yes, sir. Step per mute, mute, mute. Yes, sir. You are audible.
Yeah, wait a minute, please.
Yes, sir.
But
Mute. Unmute.
am I audible to you now?
Yes, sir.
Okay, fine. So the second thing is, it is a more cleaner fuel than the rest of the fuels that we are talking about. Like in the renewable energy sources, we are talking about, like for example, the green fuels, or the geothermals. We are talking about the wind energy. We are talking about the fossil fuels. But if you see that most of the fuels having that the emissions, and the which is environmentally, the problem create the environmental hazards. But this is considered to be one of the cycles fuels, which is the CH3 emissions or the zero emissions. The second is the fast. It is faster refueling that times. So when you talk about the most of the fuels, it is better than the having the last emissions energy, and have a energy more than the rest of the fossil fuels requirements. So we talk about the what are the advantage of these fuels. So next slide, please.
Major advantage.
So it is will give you an idea. The first is it is clean and the zero emission fuel that we are talking about. Productions and the powerful the fossil fuels compared to the fossil fuels, and the abundant and the inexhaustive. Like for example, if we talking about by the times even we have 78% the water on the earth, obviously you can easily convert the water. So water will give you an hydrogens, and automatically when you convert this hydrogens, and again it will give the oxygens, and will give you the H2 itself. The another main point is there is no noise pollutions. If you're talking about the the cars and all, or the automobile industries, when we are using this automobile industries, every vehicles that is using it in that conditions is not emissions any kind of the
Next
emissions,
करते हैं, next
and also noiseless, and even the it is noise free. So most difficult than the energy sources, but because storage is the problem with the hydrogens, we'll talk about the better also, but most efficient than the other energy sources, and can be used in various factors. Can you change the slide, please? Okay. So this will give you a graph of overall, supply and demand of the hydrogens in every sectors. If you see that the upper portion of this supply, so how it is going to be fossil fuel, renewable energy sources, and the nuclears, and can be subdivided into the various parts of it. For example, if we talk about the fossil fuels, so we have a coal, we have the other natural gases also, the natural energy, and in the renewable, we are talking about the even the different. So geothermal, any other kind of the materials, and the other part is the nuclear one. So everybody knows, like more than 60% of the demands of the birds is one is wind energy, and the last one is the primary energy. So if you see that there are various productions methods or the sources by which we can easily convert these sources into the hydro energies. And the last one here we talk about the nuclear energy. The important part, that is we talking about the demand of this hydro energy in the various sectors. So even it is through the portables, so in the transportation itself, through the buildings and the industry itself. So everybody knows that the main resources that we require energy is the petroleum sectors. The second is through transportations, and the third one is in the building energy or the buildings. So if we say that turbines and this process synthesis or power generations, actually this requires much more the energy than the requirements. So if we are coming up the synthesis process in such a way that it is easily, if synthesis in small kind of industries, then it will be easy for us to deliver the hydrogens to that, especially industries, the building also, and the PC sections also. Can you come up the next slide, please? I don't know how many of you heard that even hydrogen is come up with the, you know, you can say that different types of hydrogens. I don't know how many of you heard about it. Like, but even hydrogen is have at least five classifications, usually five six classifications. So it is has green hydrogens, it has yellow hydrogens, it is called the pink or the purple, blue, turquoise, brown, oblique black, and the gray and the white hydrogens. You must be surprised that uh, that depending upon the synthesis productions process, it is divided into all these categories. Like if we talk about the green hydrogens, so green hydrogen is must be 100% renewable energy sources such as solar, which is generation from the zero. Like for example, in an example. But what about the like the blue or sorry the gray or even the brown one, black? So when apart from it is coming from the industries or the synthesis process or the renewable in, energy process, then it's called the black or the brown or called the brown or the black process. Like for example, if we extract from the coal and through the gasification reaction, if you are gassing out the synthesis, this hydrogen, this is called the brown or the black hydrogens. Like in this case, if we're talking about the blue hydrogens, and then blue hydrogens must be extracted from the natural gases, and which is the for the stage reforming where CO2 is captured and is either stored or in the different ways. That's called the blue hydrogens. You must be surprised that even these all have divided into the different colors, and mainly we talk about the yellow colors. So this is mix of the energy resources such as renewable and the fossil fuels, and come up with the white even. So it is if it is coming up the byproduct of the industries, then it is called the white hydrogens. Next slide. So if it is like what is the main focus why India or the world is actually striving to search for this hydrogen energies. So the first point, which is the main point, is the hydrogen protections. So the main housework being the electrolysis process, supported by the other routes exploits such as sunlight or the thermal dissociation of water, solar energy through photocatalysis, biomass of gas, and biological use. So normally we will talk about in the coming slides all these use. The second is focus on the hydrogen and the storage distributions. Because even if it is hydrogen is produced, but the hydrogen storage also you can say the difficult task to storage in a manner. So in that conditions, the specific area, hydrogens in the nitrocates and the liquid hydrogen barrier. So there are so many things we have to take care of when we are going to store the hydrogens. Hydrogen end use, because ultimately users is the end users of the person. So how it is going to be synthesized in the first part. The second is the hydrogen storage, and the third one is the third point or the one is the hydrogen end use users. started with solar panels on the, giving the energy, which is probably considered to be the first word in the words, which is totally, you can say, the CO free energy, and use it in the data centers. And the ideal end use is for the clean hot wind powers. So overall goal is here is to support the Indian supply chains and to develop the portfolio of the solutions which will provide the clean energy and the renewable energy sources. The next slide, please. So hydrogen demands is an increase. You can say the hydrogen demand is a need of the market, the need of the world. If you see that the year wise data is given to you, and in which hydrogen is produced from the various countries, which will help you to understand that how much of the hydrogen is producing from the various countries in the world. Like in the, we have the India even. India is in the middle of it. It's not, you can say, the large quantity of hydrogen is produced from the various synthesis process, but in the mediocre, where it is like 25 to 30 million metric tons of hydrogen is produced from the various sectors, or sorry, various synthesis process in the various sectors. Until now, North America, or you can say the America, is considered one of the best for producing hydrogen. And below them we have a Europe and the other Asias and China and the Middle East. Next slide, please. This slide is very important to understand that if you see that how much of COX is emitted from the various resources when the hydrogen is produced. If you see that, this will give you an idea. Like natural gas production distribution give you 25% of the hydrogen is produced per kg of the hydrogen is produced from the sources. Electricity generations will give you the 2.3%. In the case of construction and demolitions, it will give you the 0.4%, and the avoided operations like -2.5. But mainly considered to be over the 75% of the hydrogen is, you can say, the produced from the hydrogen operation plants, which will give the mainly COX or the CO2 in the industries. So can you imagine that for 1 kg of hydrogens, at least 12.3 kg of the CO2 is emitted. So do you see the difference? So if you want to synthesize 1 kg of hydrogens, but you have to synthesize, or obviously it will give an operation or the idea like 12.3 kg of CO2 is emitted by synthesizing of this any process which is giving you the hydrogen energy. So that's why we are seeking for the alternative sources by which we can get easily the what are the various ways by which we can get the renewable energy, or the, we can say, the now we can say the green hydrogen energies. Next slide, please. So this will give you idea now. So we have the various ways on the left hand sides, through the wind, through the sun, through the Mars, natural gas, or maybe the coal will give you the different ways to convert this by the various process, which may be electrolysis, it may be of gasifications, it may be of pyrolysis, SMR, steam reforming methods, which will give you the hydrogens. On the right hand side of the slides, we give you what are the different processes used right now used in the industries, which is mainly synthesize the hydrogens. One of the most commonly process used is the steam reforming process, which is considered is like almost 60%. Coal gasification is considered to be the second one. As we go on, you know, the down of these portions, you will have the electrolysis process, biomass pyrolysis process, but we have the limitation of these processes too. But if we talk about the various process, we'll only today in the slides or today conversation we'll talk about the process we have never heard about it, or maybe you have a little the a little idea about it, why this process is useful, because it is very new and it's in the pilot plant itself. So we'll talk about the mainly the three production process one by one, which will give you an idea how this is synthesized in the उनका जो भी जो पोर्शंस है जो कि बिल्कुल यूज नहीं होता, उन प्रोसेस को हम अगर हम यूज करना चाहें, that is considered to be the feedstock of this. So that is called the residual part of it. So if you use the residual part and going and throw it in the gasifiers after the salification of it, then it will gasify it and it becomes converted into char and the gases. When it is comes in the gases, then the other process is called the gas unification reactions, in which the synthesis gas or the syngas is produced in this process is to be cleaned, and then after cleaning, like for example, it is converted in the next slides. We'll get to know the process. Can you just come to the next slide, please? So that will give you an idea. So next slide, please. So these are the basic reactions actually that's occurred in the biomass to hydrogen fraction process. So the carbon is there. So in the convergence of hydrogen, it will be converted to the syngases or the H2 and CO. And after this again, it is converted to the shift reactions, which is convert this C plus H2O convert into twice of H2 and will give you the finally the shift reactions will convert only the hydrogen energy. EVX is the hydrogens. But the main problem with this, if you see carefully the both the reactions, you will find that in all the process, all both the process, we will have emissions of CO and CO2, which is the main issues that we try to avoid it in the main, or we can say the for going for the renewable energy method. So if you see that both of these processes emit a large amount of CO and CO2, which must be reduced. So, which I gave you an example of the previous slides, where we have an idea that per kg of CO2, 12.7%, about 12.3% of the kg of the CO2 is emitted per kg of hydrogen fraction. So we will give an example of this. But how the system works is biomass is controlled in a controlled atmosphere, and then in this conditions the methane is released, and then methane is converted and then separated into the conditions of H2 or the syngas is converted into the hydrogens. So in this raw methane and the clean hydrogen is used as fuel, and which will be called the renewable energy sources for these conditions. Can you come to the next slide, please? The second, we can talk about the previous slide, please. Previous slide, please. Yes. The second you have not heard about is this is the latest development in the various industry, and that is in the private space. So methane is converted to hydrogens. We have already talked about the basic reactions. Maybe you have studied this in the basic of 10th and 12th. That methane is converted easily to the carbon and hydrogens. We have already known. But what is interesting in it, till today, that the carbon is produced from these reactions is mainly comes in the carbon forms, not any other forms, which will give you the COS. Okay, but right now the research has started, and if we talk about the research and how we can use this carbon as a source. So in this, actually, if we are going to synthesize and or the development of the different catalysts, which will can easily usable all these carbons into a different form, then it will be called the COX-free hydrogens. Like for example, this in these conditions, the COX-free hydrogen is desirable, and the carbon that is produced from this source, it's in the form of fibers or the graphites or maybe the catalyst, of course. So if you see that almost all of you know that the carbon or the fibers or the graphite, is very costly. Or the carbon that is produced in this condition is very costly. Like says 1 gram of even 1 gram of carbon nanotubes that cost 3,000 to 4,000 rupees. So if we use this hydrogen as such, sorry, the carbon as such as the as a byproduct as such. So it will be now in the win-win situations for the industries that the all the hydrogen is produced as such in the conditions that that the carbon is also the renewable energy sources. The Slide, please. So now you can say, what is the importance of this process? So this is called the thermocatalytic decomposition process, where the carbon and the hydrogens. So hydrogen is CH3 and the carbon is formed in the case of the carbon graphite or the carbon nanofibers. So this is, you can say, if we compare, do the comparison from the biomass or the SRM, the steam reforming agent process, you can say that the global hydrogen productions of the hydrogen produced via SRM is comparatively very, very low, or the, you can say, the negligible. So that's why everybody is now coming up with the various technological development and try to, insist on this study from the last 2 decades and try to develop a catalyst for this. Can you just go to the slides, please? The important part in this process is the catalyst development. I have my, I'm pleased to tell you that in my research, we have synthesized or the develop of a catalyst in these conditions, which is US patented from my research, and that has behaved of more than 5 patent in this. So we have 2 US patent on this catalyst development and one Canadian, and the other one is the world patent on it. So that will give you the energy development and will give you the more than 95% of the hydrogens, that is almost CO-3, 95%. And which is even the carbon that is produced from this is carbon nanotubes, which is very costly. As I give you an example, 1 gram of even, graphite or the carbon nanotubes that cost, 3,000 to 4,000 rupees. So this is my, from the research, and you can say it is very simple process. Can you come up the next slide, please? So this is very simple process in which what we are doing is, we set up an example like methane, hydrogen cylinders through the, flow controllers. We give the preheaters, and we have put it in the in the furnace or the reactor systems, in which at the different reaction conditions of the reactors will give you the CH3 hydrogens. So we have the temperatures, like, which is varying from your temperature from like 500 to 700 or 750 degrees C, and it will give you the carbon in the forms of nanofibers or the nanotubes and the CH3 hydrogens. Can you come on the next slide? So this is the carbon nanotube system. You can see from this, which is very, very interesting for you. So we can synthesize these hydrogens at the research lab, which is very, very, dense is formings on the various catalysts. Just to get to know that we are working, we worked on the nickel based catalyst and the cobalt based catalyst on this, and at the different processes of it. Can you come up with the next slide, please? So this is the, higher magnifications. Earlier was the STEM slides. This is the TEM, transmission electron microscopy, which will give you an idea how much of carbon and use length and the diameter of it. So you can have an idea how the carbon nanotubes is start working and what is the importance of this. We will read it maybe in the later classes also. Uh, the another part, which is, you can say, the renewable part of it, is from the solar energy. We'll not talk about the, all the things, but the important part is we have the primary energy in it. So the primary energy is like, we have the primary energy, we have the hydrogen feedstock and the production methods. So even from the, from the solar energy, we can easily divide it into the at least, seven to eight part of it, or the process actually. So we can say that the photon, like for example, if we talk about the left hand side of it, with the when the photon is, added in the water, we have the different three types of the process, which is called PV electrolysis, photocatalysis, photoelectrochemical process. We talk about that. And the electrical, so when it is comes, the electrical energy is used in the water through the electrolysis. We have the alkaline electrolysis, high temperature electrolysis, and the PM electrolysis. And when it comes with the thermal and the biochemicals, and we have the different production process. What is interesting, you will find it in all these process. Every researcher is working on every kind of the process, main thing is we have some limitations of the efficiency of metals. Because, like for example, if you talk about the photobiological process, because it is dependent on the biological process, so it is very slow process itself. So when it is slow process itself, so for the industry, it is not easy for them to wait for like 2 3 days, and when the biological process will start and give you the hydrogens. So we had with the limitations of the time constraint also. So when we have the electrolyzers and the thermal water splitting, so we had in the case of thermal water splitting, we had to raise or increase the temperature up to 500 or 550 degrees C. Then the water will split, and then it will convert to the thermolysis process. We can get the hydrogens. In the interesting way, we'll tell you only about the one process which is called the photoelectrochemical process, which will give you an idea how it is going to be produced from the thermoelectrical process. Coming on the next slide, please. So, through this process, this is called the photoelectrochemicals process, in which we are having a small, uh, bracket. Everybody knows about the semiconductors. Every semiconductor metals has semiconductor means we talk about the uh, titaniums, we talk about the scandiums, we talk about the coppers. So all these metals which are called the semiconductor metals, which is useful for the synthesis of or the used for the splitting of the hydrogen process. Just the basic of it. So if you see that how it is going to be useful, so the hydrogen or the water is split into the two parts. So hydrogens is evolved like in hydrogens and then electrons, or you can say the holes and electrons. In the this is called the reduction of the hydrogen ions, and the oxidation reaction we have the hydroxyl ions, which is converted into the hydroxyl ions plus OH is called the whole. The left hand side will give you an idea why it is useful for the semiconductor metals. So, like the basics of this, we have already studied in your 10th and 12th classes. So when we were in the 10th 12th classes, we have talked about the how the electron is passed from the valence band to the conduction band. So now imagine let the some of the photons are getting some higher energy, and that conduction band, this electron is now shift from the valence band to the conduction band, and on these bands both of the reactions are occurs. So you can find it. We have the band structure of the some of the semiconductor bands of the various metals that is used today. And the most important that is for the splitting of hydrogens or the water actually, we need 1.23 electron volts to split water to the hydrogens. And if we are using that semiconductor metal higher than that, you require much more energy. If it is less than that, it is not possible for the metals to having this kind of energy, so that reaction will not be possible. So we had to uh, think about it very carefully. Which metals, or sorry, the semiconductor metal is useful for splitting the hydrogens. Coming to the next slide, please. So this gives you an idea and how these reactions will occur in this uh, PC reactions or the photoelectrochemical water splitting process. So in the upper portions, hydrogen is what, and the lower portion, the energy requirement is 1.23 electron volts. So when you can see from the the figures, when this electron is excited, electron will going to the upper portions, and that's called the conduction band. So electrons are here. In the lower portions, the holes are created, which is represented by the H. So in this valence band, hydrogen is evolved, and the lower portions, sorry, and the upper portions, and through the electrons, this hydrogen ions will convert into the hydrogens. So if it is energy requirement is higher than that, then it is going to be difficult for the the metal ions to be produced in these conditions. Also, the energy requirement will be very high. So, like for example, if we take an example of titanium oxide, which was established, semiconductor materials, and through the like titanium oxide is used when it impinges the you can say the photon on it, will convert into the hydrogen ions and the electron ions. So what actually happens is in the state wise, the reactions of the electrons and the hole pairs, which will give you the surface and cause the reactions of hydrogens to the hydrogen ion to the hydrogens, and oxidations of the H2 to the oxygen respectively. The next slide will give you an idea how the process will be helpful and how this process is going to be synthesized, or you can say the just an basic just hold on please. Wait. Okay, sorry for the disturbance. We continue this. So this is a schematic diagrams of how the hydrogen is evolved in these conditions. So if you see the right hand side figure of it, it is very useful to understandable that when this sunlight will impinge on the surface of any semiconductor metals, it will excited, you can say the excited, the semiconductor metals and will have the electrons and the hydrogen ions. So what will happen? But this electrons and hydrogen must be separated so that you can say the reaction will be positive. And it should not be recombination. If it electrons and hydrogen will recombinations, then the reaction will not occur. So it is a mandatory condition for the electrophotochemical reactions. Then it should be separated and it should be come to the surface for the reactions to be occurred. If you see that the photocatalyst is there, so on the left hand side of it, it is for the co-catalyst is there, and when it's come to the co-catalyst on the electron side, then the hydrogen will be evolved and the oxygen will also evolved in the left hand side of it. So you see that on the photocathodes will get the hydrogen, on the photoanodes will get the oxygen. After this synthesis, all these synthesis process, the interesting part is like even the hydrogen is evolved, how is going to be stored in it. So by the times we'll be having this physical base and the metal base. So we can easily divide this into two parts. The first is the physical base. The first one is the compressed gas or the cold, and the second one is cold, and the third one is into the liquid. We'll talk about this in the next first knowledge. And the third part is in the metal base. So the adsorbent, liquid organic, industrial hydroxides, or the complex hydroxide, or the chemical hydrothermal are the different materials that they use for storage of the hydrogen. Can you come on the next slide, please? Okay. So this is metal hydroxide. So what will happen? So especially combinations of metals that or the alloys. The condition is it should be alloy. It should not be burst in that condition. Then we should be very careful while using the metal hydrates. And that possess the ability to absorb hydrogen and release it better. Because hydrogen is gas conditions, so it should be first absorbed, and when you require that hydrogen, it should be release it in the later conditions. And this hydrogen absorb is generally 1 to 2% of the total percent of the gas. So now almost all of you know that so many companies, even the now even in India, apart from this BMW or the Mercedes or the Ferrari, now India has come up with this storage tanks, and which will be used for refilling of these hydrogens in the various automobile sectors. Next slide, please. The second one is the compressed hydrogens. So first one was the metal hydride. The second one is compressed hydrogen. It is very difficult for every industries to compress hydrogen because the calorific value of this is very high. So it is very high to compress, but still the hydrogen is should be compressed at the high pressure sometimes, and should be extremely hot because of lot of the energy requirement is there. So hydrogen can be compressed at very very high pressure slides, which is have a tank pressure of 6,000 psi. It's called the, you can say, if it is it's like a small pump, we have to take care of very very carefully even at the compressed sites. The third process, you can say, through which we can store the hydrogen is the liquid hydrogens. So hydrogen does exist in the liquid, but is only and only possible in the liquid hydrogen conditions, or the even the minus 273 temperature, and a pressure of very lower pressure of like 1 bar or 0.1 millipascal or gigapascal, sorry. So can you change the slide, please? So when you decrease the temperatures, then only it is possible to liquefy this hydrogen, uh, and then only it is possible to liquefy this hydrogen and keep it in the vessel. So it should be a super insulated to store the hydrogens so that it cannot be evaporated and keep the container cool. So you can see that the small SS, you can say, the, or the stainless steel or the other kind of metal dies, which would be helpful for making the cylinder tanks in the conditions. So you can say that now the India also coming up with synthesis of this liquid hydrogens. You can easily use it. Come to the next slide, please. Uh, if you see that why it is chemically stored, the or the hydrogen energy or the glass level stores, so most of the abundant elements often found in the numerical compounds, and the various techniques like ammonia cracking, partial oxidations is there, which will be helpful for making this also. So coming to the next slide. So now you can see the easily comparisons. So this is the tank volume required, the pressure requirement, temperature requirement, the storage capacity. So if you can find that, if you see the right hand side of it, so for 1 kg of store capacity, you can easily realize how much of the volume is required for high storage. So like even the for the higher storage pressures, you the volume requirement is very very high, and that is the 280 liters compared to, like, for example, it is converted to methanols or the uh, or the metal hydrides. We are obviously we are talking about the in the previous slides. But the condition is, in these conditions, the temperature requirement is altogether different. You see that when if we are talking about the liquid nitrogens, in the case of liquid storage, the temperature is very very low. So this is minus 253 degrees Celsius. So to maintain it, to store the liquid in this condition is very very tough, and making it is possible in a manner that it safe. So what is the strategy to how the hydrogen is going to be safe, safely stored? So like this will give you an idea. Hydrogen center or the gasoline vapors and the leaching gas, if you see flame temperature, you can see the flame temperature of it, then give you the hydrogen have a flame temperature of 245 degrees C. While in case of gasoline vapors and the other natural, you can see in the right hand side portions, when the hydrocarbons is burned, it's come with the red slides. But when we talk about the uh, hydrogen is burned, it's come with the blue colors. So you see the difference between these two flames even, which is going to be burned at which side of it. So safety guidelines while using hydrogen as a fuel to avoid formation of lower explosion liquid matches, and early detections algorithm for hydrogen leakage from pressure vessels during storage, and the protocol should be adopted for avoiding transportation hazard to the process. Coming on the most, you can say, in the text of context of India's initiatives. So the green hydrogen missions have mainly focused for the 8 points. So first, the site, you can say, the basically domestic productions, is the pilots plants. So first synthesis in the laboratory, then comes the pilot plants. Then third, we are talking about the from the very beginning we are talking about the green hydrogens, because it is already we are synthesizing the hydrogens from the gray and the black, but we are talking about the
क्वेश्चन लिख लो क्वेश्चन अरे क्या बोल रहा है क्वेश्चन इज आस्क्ड भाई वहाँ नाम लिखा होगा जिसका भी उसका बोलना फिर उसका क्वेश्चन बोलना उस पतोली में चार पांच लाइन उसके बाद बोल देना थैंक यू सर फॉर डाउट आई थिंक हिज डाउट इज क्लियर कौन सा क्वेश्चन तीन क्वेश्चन वो बोल लो दो क्वेश्चन दूसरे को बोल ये दोनों मेरे को बोलना देख जो सब बोलना ये ये बोलना तो देख रहा तेरे को जो अच्छा लगे ऐसा ये वाला छोड़ ये सब नाम लिखना है जिसमें नाम नहीं लिखा है उसमें किसी का नाम लिख दे this question is asked by Satyam from 2 into Yal बोलेगा this question is asked by Akash from 19 क्वेश्चन और पूछना होगा तो अपने क्या सिंथेसाइज सिंथेसाइज ये भी कौन स्टार्ट वो करेगी ना पूछ ले अंजलि से पूछ लो ठीक है ठीक है ठीक है this one and this one okay राष्ट्रीय राष्ट्रीय बोलने के पहला क्वेश्चन फिर को कंप्लीट वो माइक से आवाज नहीं आना ला ला ला
Good evening, sir. Hello.
Unmuted.
नहीं unmuted.
Thank you, sir. Good evening, sir. Sir, I am Rajshri from Civil Engineering branch of Batch 2K21. Sir, I have one question that other than hydrogen, what are the other alternatives of ideal fuels?
As we have already talked about, because now we have already, many of the, like in the 20 years, we are talking about the fossil fuel only. Now we are talking about the renewable energy sources, and particularly we are talking about the geothermal, wind energy, nuclear energy, because all these energy don't emit any kind of, the COs. So what the problems till now we are facing, we are only dependent on the northeast. We can sorry, the Arabic countries for any use of, any kind of the fossil fuels. So if India is like almost, you can see the 75% of the India is covered from like from Gujarat to again into the West Bengal. The lower portion of part of India is covered by the water. So if we are coming up with the any technology which is easily, produce electrolysis process, or we can easily split the water into the hydrogen, then the problem will be solved, for many many years, because it is uh, renewable energy process, and exactly you can say the, it is CO2 emissions. So we'll get the water, get the hydrogens, and hydrogen is very useful in the condition we can again use it the hydrogen, and we'll give the water. So it is the, a cycling process that we can use it, and with no, you can say the, no deficiency of any kind of the things that which we always requires for the environment.
Uh, okay, thank you, sir. Sir, there is another question from Pradeep, sir, of Batch 2K19. Which is more feasible for Indian market in transportation sector, either lithium or hydrogen powered vehicles. We have just found, India has recently found lithium reservoirs.
Very true. Very interesting questions. But in terms of, the sources, almost all of you knows that the lithium extractions is the main, again, a very tedious process. It's very very tough to dig up the and to reach up to lithium is like, 1,000, you can say the fits, the bound, in the earth crust is very difficult, and that too with the, lithium is not, like in milligrams.
Is satisfied with your
So the
answer.
problem is like for the making this lithium into the milligrams, again it is very, environment, you can say it's not environment friendly. So if we are coming up with, again I'm talking about the renewable energy sources. अगर हम लोग अगर renewable energy की बात करें, तो अगर हमारे पास अगर ऐसा कोई सेटअप हम एस्टेब्लिश करें जो कि पूरा हमारे पास नॉन रिन्यूएबल हो, जिसका हमारे पास है ना, मतलब जहाँ पर हमें है ना इन सब प्रोसेस जो टीडीएस प्रोसेस हैं उसकी जरूरत नहीं पड़े, तो वो हमारे लिए बहुत इजी होगी. Lithium, I found it is very easy to store. Storage capacity is also high. We are using in, many of the, devices. But again, the problem is it is not environment friendly. So we have the constraint even using the lithium up to a certain limit. So hydrogen is one of the best sources in terms of, the transportations, in the industries, because in one of the slides I gave an example. 75% of the, the CO2 emission is from the industries only. There's only, like if you're talking about the domestic process, this is only, 2.5%. So till now we have to, search for the other options, and you won't believe that Sweden is. You can just read it on the Google even. Sweden is come up with like, wind powers that is almost more than 80% now, because they have the renewable energy sources. So now we have India also seeing this kind of things. आपको ये भी जान के बहुत अच्छा लगेगा कि हमारे पास जो सोलर पैनल्स हैं, इंडिया के अंदर बहुत सारी जगह ऐसी हैं जिनको इंडियन गवर्नमेंट ने, दैट वाज वी आर टॉकिंग अबाउट द यूनियन इनिशिएटिव्स, जैसे कोचीन का जो एयरपोर्ट है, दैट इज ऑल टुगेदर, डिपेंड अपॉन द सोलर एनर्जी. तो सोलर एनर्जी जो भी प्रोडक्शन होता है उसको हम वहाँ पे एनर्जी को यूज कर रहे हैं, विच इज 100% एनवायरमेंट फ्रेंडली. इसी तरह से और भी इंडिया ने, जैसे एक ट्रेड में आपको बताया था अभी कि स्टार्ट करी है, जो कि सोलर पैनल्स को यूज करके करी
Okay, thank you, sir. I think that Pradeep sir must be satisfied with your answer. Okay. Sir, we have next question from Akash sir. How we can commercialize hydrogen as fuel in automobile industry? Yes, sir, we had.
Yeah, thank you, sir. Sir, we have one more question from Akash, batch of 2019. Sir, can hydrogen fuels fully replace the fossil fuels? Yeah, thank you. Yeah, thank you, sir. We have a last question of this session. This question is asked by Satyam, batch of 2K19. So, what is the process of synthesized carbon nano tubes? Yes, sir. Yes, sir.
हमारे पास जो मैंने आपको प्रोसेस बताया इसके अंदर है ना थर्मोकैटालिटिक डिकम्पोजिशन ऑफ मीथेन प्रोसेस, मतलब अगर आप नेचुरल गैस है आपके पास और अगर उसको सर्टेन प्रेशर और टेम्परेचर कंडीशंस में और सुटेबल जो कैटलिस्ट है उसके ऊपर हम अगर यूज करें तो कार्बन नैनोट्यूब्स बनते हैं, अदरवाइज नहीं बनते। तो अगर हमारे पास अगर कार्बन नैनोट्यूब्स बनाने हैं जिसके लिए मैंने आपको बताया भी था, जो हमारे आईआईटी दिल्ली में जो मैंने रिसर्च करी है उसमें मैंने पेटेंट भी कराया है उसको, तो हमारे पास जो कार्बन नैनोट्यूब्स बने हैं उसकी क्वांटिटी की मतलब 1 ग्राम के ऊपर 2.6 ग्राम ऑफ कार्बन नैनोट्यूब्स वाज देयर। मतलब 1 ग्राम अगर हम कैटलिस्ट यूज कर रहे हैं तो आप इमेजिन करें कि उसका ऑलमोस्ट ढाई मतलब 2.5 ढाई गुना हम कार्बन नैनोट्यूब भी प्रोड्यूस कर रहे हैं, और उसके बाद जो कार्बन सॉरी जो हाइड्रोजन प्रोड्यूस हो रही है वो भी 99% प्योर है। उसको आपको प्योरीफाई करने की, मतलब आप उसको चाहो तो उसको हाइड्रोजन को सीधे आप फुल सिस्टम में यूज कर सकते हो, इतना प्योर है वो। तो वो डायरेक्टली प्रोसेस है, उस डायरेक्टली प्रोसेस को आप तो कार्बन नैनोट्यूब्स भी आपका प्रोडक्शन होगा, लेकिन कार्बन नैनोट्यूब प्रोडक्शन का केवल यही मेथड नहीं है, सीवीडी जो मैंने आपको बताया टीसीडी मेथड, थर्मोकैटालिटिक डिकम्पोजिशन मेथड्स। वैसे तो हमारे पास वेपरेशन प्रोसेस भी है, सीवीडी मेथड जिसे बोलते हैं, वो भी आप यूज करते हैं, और भी अदर प्रोसेस हैं, लेकिन इट इज रियली टफ प्रोसेस। लेकिन अब जो है कुछ पिछले 3 साल में डेवलपमेंट बहुत अच्छे हुए हैं जिसमें कार्बन नैनोट्यूब्स को, क्योंकि इनकी स्ट्रेंथ बहुत अच्छी होती है, इनकी कंडक्टिविटी बहुत अच्छी होती है और इनकी प्रॉपर्टीज बहुत अच्छी होती है, तो अब बहुत सारी इंडस्ट्रीज के अंदर इनको यूज कर रहे हैं। इवन यू आर वंडरिंग कि हमारे पास हम कपड़े यूज कर रहे हैं, जो फुटबॉल यूज कर रहे हैं, उसके अंदर भी इनको यूज करने लगे हैं टू मेक द स्ट्रेंथ स्ट्रेंथफुल ऑफ द मेटल्स। वो आपने देखा होगा।
Yeah.
So I hope you get my answer.
Yeah, got it, sir. Thank you, sir, for dispensing your valuable knowledge towards us, and we are very delighted to have you, sir.
Thank you so much, and thank you all the students and Professor Ranjay Singh sir, and regards from my you know to all the MIT persons who are present here. Thank you.
I appreciate their thought-provoking points, sir. The students are undoubtedly learning many more things from Avlokan. Thank you so much for coming and bestowing us with your presence. Thank you doing so much for us.
Thank you. In conclusion, Samvad has been a truly enlightening experience. The panelists have provided us with valuable insights and perspectives on the theme of event, and it has been an honor to listen to their thoughts and ideas. And it's just the beginning. We have more spectacular events coming for this Science Week, and we will request all the students here to voluntarily be part of this event.
थैंक यू। चलो चलेगा क्या?